grab the function f of x equals square root of x plus 5 and find the domain of the function. We're going to find the ordered pairs x comma y. So I will say x, my y equals f of x equals square root of x plus 5, and my ordered pair x comma y. My first value as an x, I'm going to choose negative 5 because negative 5 plus 5 square root of 0 is 0. It's possible. But if I choose negative 6, that makes my radicand negative, which is not a real number. So the smallest value for x I can choose is negative 5. So I'm going to plug it in negative 5 at the place of x in the function. So my value of the function at that particular point is 0. Choose negative 4. The value of the function at negative 4 is square root of 1, which is 1. My next value I would like to choose is 0. So y equals f of 0 equals square root of 0 plus 5 square root of 5. Square root of 5 is 2.2, so 0 comma 2.2. My next value is positive 4 if I choose. Then my y equals f of 4 equals square root of 4 plus 5. Square root of 9 is 3. 4 comma 3. The last value I will choose is 5. Y equals f of 5, or value of the function evaluated 5 is 5 plus 5 square root of 10. We round to the value of square root of 10 to the nearest 10th place. So that value will be 5 comma 3.2. We plot all these ordered pairs and connect those ordered pairs with a smooth curve, and that will be the graph of the function f of x equals square root of x plus 5. So my negative 5 comma 0 is here, my negative 4 comma 1 is here, my 0 comma 2.2 right here, my 4 gives me 3, which is right here, and my 5 that gives me 3.2, which is right here. We connect all those ordered pairs with a smooth curve. So this is my graph of the function y equals square root of x plus 5, or f of x equals square root of x plus 5. The domain of the function. What is the smallest x value I can choose for this particular graph of the function? And what was the range value I got for that particular smallest value for x? So the smallest x value I can choose is from negative 5 and go up to all the way up to infinity. So my domain is from negative 5 to infinity. And at that particular point, my range was from 0 up to infinity. So it goes from 0 up to infinity this way. So that's my range of the function. Now let's grab the second graph, which is f of x equals radical x plus 5. So I'm going to write my x here. My y equals f of x equals square root of x plus 5, and my ordered pair x comma y. When I plug it in x equals 0 in my function, what I get is the value of the function at 0 is square root of 0 plus 5 is 5. When I plug it in 1, I get f of 1 equals square root of 1 plus 5 is 6. If I plug it in 2, then I get square root of 2, which is 1.414. I add into 5, we get 6.4. Next one, I would like to plug it in 4. F of 4 equals square root of 4 is 2 plus 5 is 7. And the last value I would like to get is 8. Value of the function at is 9. The value of the function at 9 is square root of 9 plus 5 is nothing but 8. So plot these ordered pairs into the rectangular coordinate system. So 0 gives you 5 right here. 1 will give you 6. 2, that gives you 6.4, which is basically here. Then 4, that gives me 7 right here. And then 9, that is going to give me 8, which is right here. So connect all these points with a smooth curve. So my graph of the function is going to look like this. So my y equals square root of x plus 5, or I can say f of x equals square root of x plus 5. What is the domain of the function? What's the smallest x value I can choose? From 0 up to infinity. So that is my domain. So my domain is from 0 to infinity. My range. what is the y value I get, smallest y value I get when I use the smallest x value to plug it in into my function is 0. So my value is y. So my range is from 5 to infinity. Now let's look at differently. Can I grab the domain and the range? Can I find the domain of the function without graphing the function? So answer is yes. We just have to follow these 4 steps to write the domain of the function without working out the entire problem. And those 4 steps are like this. Step number 1. Set the radicand greater or equal 0. Step 2. Solve for the variable. Step number 3. Graph the inequality. And step number 4. Write the domain. So in my case, my radicand here is square root of x plus 5. In that function, my radicand is x plus 5. So I'm going to set my x plus 5 greater or equal 0. That is my radicand in my function square root of x plus 5. I'm going to solve for x. That means I subtract 5 on both sides of the inequality. So I get x greater or equals negative 5. I'm going to graph this inequality. Starts from negative 5, goes up to infinity. So my domain is from minus 5 to infinity. This domain does match with the domain we found with the graph of the function. Now let's do the second function and find the domain of that function without the graph. So my radicand here is x. I'm going to set x greater or equal 0. I'm going to grab that inequality. We don't have to solve it. Goes from 0 to infinity. And if I write this domain into interval notation, it's from 0 to infinity. And for sure, this domain matches with the domain with the graph of the function. Hope this will help you.